We now move to the Internet's influence on logistics. The first point on this slide is that Internet use has grown dramatically. A much larger share of the world's population is online today than at the beginning of the 21st century. That widespread connectivity has reshaped how companies interact with customers and partners. The slide highlights 3 specific ways the Internet affects logistics. First, online retailing changes how orders are placed, how products are stored, and how they are delivered, especially in the last mile to consumers. Second, cloud computing changes how logistics software is acquired and used, allowing firms to access powerful applications over the Internet without owning all the underlying hardware. Third, electronic procurement uses online platforms to transform purchasing activities and relationships with suppliers. As we discuss these influences in more detail, try to connect them to your own experience as a customer. When you track an online order, use a cloud-based application, or see an organization using an e-procurement portal, you are experiencing some of the changes described on this slide. In Vietnam, the rapid growth of online retailers like Shopee, Tiki, and Lazada has dramatically increased the demand for last-mile delivery services, urban warehouses, and real-time tracking information. These platforms could not operate at scale without the Internet as the backbone for ordering and communication. Internationally, companies like Alibaba and Amazon have built entire ecosystems around Internet-enabled ordering, tracking, and customer service, reshaping expectations of delivery speed and transparency worldwide. Follow-up question. Think about your own online shopping habits in Vietnam. Which logistics-related pieces of information, for example, delivery time estimate, tracking, return policy, most strongly influence your choice of platform or seller? This slide compares online and in-store retailing and points out their similarities from a logistics perspective. Regardless of where the sale takes place, on a website or in a physical shop, the underlying logistical functions and activities are very similar. Both channels require transportation to move products from suppliers to storage points and then closer to customers. Both need warehousing and materials handling to store and move goods safely and efficiently. And both rely on order management processes to ensure that the right products are available when and where customers want them. In terms of equipment and materials, both online and in-store operations use technologies like barcoding and warehouse management systems to identify, track, and control inventory. The key message is that the fundamentals of logistics do not disappear in the online world. What changes is how these activities are executed and coordinated. As we move to the next slides, we will focus on those differences. For now, ask yourself, in a company you know, which logistics functions are truly shared between online and store channels, and which are managed separately. A Vietnamese customer might buy a carton of milk at Vinmart, in store, or order the same item via an app like GrabMart. In both cases, logistics activities, transportation from factory to DC, storage, materials handling, and order management, are still needed behind the scenes. Internationally, a company like Walmart runs both large supercenters and an online store. Regardless of the channel, goods still flow from suppliers through distribution centers to reach the final customer. Follow-up question. If you were designing logistics for a new retailer in Vietnam that plans to serve both online and in-store customers, which logistics functions would you centralize and which would you separate for the two channels? Here we begin to look at differences between online retailing and in-store retailing. On the online side, orders tend to be more numerous and smaller, many individual customers placing one or a few items at a time. Order management systems must therefore handle very high volumes of transactions, and information systems must transmit each order correctly and quickly so that it can be picked, packed, and shipped on time. Because orders are small, online operations often rely on open case picking, where individual units or small quantities are picked from shelves or bins. This has major implications for warehouse layout, picking methods, and labor requirements. In contrast, in-store retailing usually involves fewer, larger orders. Shipments from distribution centers to stores are often full cases or pallets that will later be broken down by store staff. In the in-store model, products are moved, stored, and handled mostly in larger units. which allows more use of pallet jacks and forklifts and can yield economies of scale in handling. A question to consider is, how do these differences in order size and picking method affect the cost per unit handled in each channel? In Vietnam, online grocery orders on platforms like Bok Hoa Sun Online or Winmart Online typically involve one household ordering a small basket of items. The system must capture, confirm, and route many such small orders each hour. In contrast, replenishment shipments from a DC to a physical store may be only a few large orders per day, each containing hundreds of items. Internationally, companies like Ocado in the UK have built highly automated systems to manage huge volumes of small online grocery orders, with sophisticated order management and picking logic. Follow-up question: how would you explain to a store-based manager in Vietnam why the cost per unit picked for online orders is usually higher than for traditional store replenishment, even though the same products are involved? This slide continues the comparison by focusing on picking methods, equipment, and packaging. In online retailing, products are often slotted, placed in specific locations, to facilitate picking of smaller orders. Fast-moving items may be put in easily accessible areas, and workers commonly use totes and push carts to collect items for multiple customer orders during one trip through the warehouse. Packaging in online operations typically involves small cartons, padded envelopes, or bags that are suitable for holding small quantities and for traveling through parcel delivery networks. Packaging must protect individual items and present them well to the customer, often with printed labels and documentation tailored to each order. In-store retailing, a wider variety of materials handling equipment may be used, including pallet jacks, forklifts, and conveyor systems. Packaging is generally in larger cartons that hold many units and are designed for bulk transport and storage rather than individual parcel delivery. Reflect on this question: how does the choice of packaging and materials handling equipment influence damage rates, labor productivity, and customer experience in each channel? A Vietnamese e-commerce fulfillment center might arrange popular items like instant noodles, snacks, and cosmetics in easily accessible shelves close to packing stations, so that workers using push carts can pick many small orders efficiently. Each customer order is then packed in a small carton or envelope suitable for motorbike or van delivery. In a traditional DC serving supermarkets like Company Opmart, pallets and full cases of bottled drinks or rice are moved using forklifts and pallet jacks. And packaging is designed more for bulk storage and shelf display than for individual parcel shipments. Follow-up question: if you were redesigning a warehouse in Vietnam to handle both B2B store replenishment and B2C e-commerce orders, what compromises or zoning strategies would you consider so that both types of picking and packaging can be handled efficiently? Slide 24 looks at transportation and returns in online versus in-store retailing. For online operations, transportation companies with extensive delivery networks and strong experience in parcel shipments are essential. Outbound shipments are often picked up by vans and consolidated in hubs before being delivered to many individual addresses. Return rates in online retailing tend to be higher, and returns come directly from ultimate consumers. That means the logistics system must be designed to handle many small, unpredictable return shipments. Inspect the items, and decide whether to restock, refurbish, or dispose of them. Reverse logistics becomes a significant part of the network design and cost structure. In-store retailing, transportation methods and companies vary according to the buyer's requirements, and outbound shipments may be picked up by tractor-trailers or railcars carrying larger loads to stores or distribution centers. Return rates are generally lower and come from resellers, that is, from stores back to distribution centers or suppliers, in more consolidated shipments. A useful question is, how do these differences in transport patterns and return flows influence decisions about carrier selection, network design, and service policies? For online orders in Vietnam, companies like Gao Hang Nhan or Gao Hang Tiet Kiem rely on dense networks of motorbike couriers and small hubs in cities to deliver parcels directly to consumers' homes, often with cash-on-delivery options. This model involves many stops and complex routing. For in-store retailing, Large trucks may deliver palletized goods from distribution centers to big C-Go or lot mart stores according to fixed schedules. With fewer stops and more consolidated loads, returns typically flow from stores back to DCs or suppliers in bulk rather than from individual customers. Follow-up question: if return rates for online fashion orders in Vietnam continue to grow, what changes might logistics providers need to make in their transport and warehouse operations to handle these reverse flows effectively? Now we shift to cloud computing and its influence on logistics information systems. Cloud computing refers to accessing software, services, and technology infrastructure over the internet rather than owning and operating all the hardware and software yourself. The public cloud services market has grown rapidly, indicating that many organizations are choosing this model. One key advantage is the pay-per-use formula. Instead of making large upfront capital investments in software licenses and servers, firms pay based on their usage. This avoids heavy capital expenditures and can speed up the return on investment. Because cloud solutions are treated as operating expenses, they can be easier to adjust as business conditions change, scaling up in busy periods and scaling down when volumes fall. Another advantage is that cloud computing makes it easier for organizations to acquire application-specific logistics software such as TMS and WMS without having to install and maintain complex systems in-house. During economic slowdowns, when companies are under pressure to reduce IT spending, cloud-based applications can offer advanced capabilities with lower initial cost. The question for you is: what factors should a logistics manager consider when deciding whether to run a system in the cloud or on-premise? A Vietnamese SME logistics company might subscribe to a cloud-based TMS instead of buying expensive software and servers. This allows it to test the system with a few users and expand as its customer base grows, paying monthly fees instead of one big upfront investment. Internationally, many firms use cloud-based versions of SAP, Oracle, or specialized logistics platforms, benefiting from regular updates and easier integration with partners' systems through APIs. Follow-up question: imagine you are CFO of a mid-sized logistics firm in Vietnam. What financial arguments would you expect to hear from your IT manager if they proposed moving from on-premise systems to cloud-based logistics applications? This slide continues with cloud computing, listing additional advantages as well as drawbacks. On the positive side, cloud-based applications can often be installed faster and at lower cost than traditional on-premise systems. Because much of the infrastructure is managed by the provider, companies may need a smaller internal IT staff to support logistics applications. Regular upgrades and updates from the provider mean that customers can benefit from new features and security improvements without managing complex upgrade projects themselves. However, too many upgrades or changes in a short time can be disruptive, especially if they alter user interfaces or processes that employees are used to. Another limitation is customization. Cloud solutions may offer less flexibility to tailor the system to unique business processes. Security is a central concern, because access to cloud-based logistics systems depends on the internet. Organizations must be confident that their providers protect sensitive data and that there are plans in place for outages or cyber incidents. A discussion question is: if your logistics operations depend heavily on a cloud-based system, what risks do you need to manage? And how would you evaluate whether a provider is trustworthy? In Vietnam, some companies that moved quickly to cloud-based systems during the COVID-19 period appreciated how easy it was for staff to access logistics applications from home or from different locations. At the same time, frequent user interface changes or new features sometimes confused employees who were already under workload pressure. Internationally, there have been cases where outages at large cloud providers temporarily disrupted access to critical systems for many customers, highlighting the importance of backup plans and clear service level agreements. Follow-up question: if your logistics operations in Vietnam were heavily dependent on one cloud provider, what contingency plans would you put in place for system outages? And how would you train staff to respond when the system is temporarily unavailable? We now look at electronic procurement, or e-procurement. which uses the internet to make it easier, faster, and less expensive for organizations to purchase goods and services. Instead of relying mainly on paper forms, phone calls, and manual approvals, companies can use online platforms to request quotes, place orders, and process invoices with suppliers. The slide lists two categories of benefits. Transactional benefits measure the gains from enhanced transactional efficiency, shorter cycle times, fewer errors, reduced paperwork, and lower processing cost per purchase order or invoice. Automation frees purchasing staff from routine tasks so they can focus on more strategic activities such as supplier evaluation and negotiation. Compliance benefits focus on the savings that come from better adherence to established procurement policies. E-procurement systems can guide internal users toward approved suppliers and contracted prices, reducing maverick buying from non-approved sources. Over time, improved compliance helps organizations realize the full value of negotiated contracts. A question to consider is, in your view, which is harder for organizations to achieve, transactional efficiency or policy compliance, and how can e-procurement support each? In a Vietnamese manufacturing firm, e-procurement might allow production planners to order standard packaging materials or spare parts through an internal catalog linked to approved suppliers, rather than sending emails or paper forms to purchasing. This speeds up the process and reduces errors. Internationally, companies like Siemens or IBM use e-procurement platforms to manage complex global sourcing, ensuring that thousands of employees buy from preferred suppliers under negotiated contracts. Follow-up question: if your organization in Vietnam wanted to pilot e-procurement, which spend category, for example, office supplies, MRO items, packaging, would you start with to demonstrate quick transactional and compliance benefits? This slide continues with e-procurement and introduces two additional benefit categories: management information benefits and price benefits. Management information benefits arise because electronic systems capture and organize detailed data about purchasing activities. Managers can see who is buying what, from which suppliers, at what prices, and with what delivery performance. Such information supports better spending analysis, supplier performance evaluation, and strategic sourcing decisions. For example, a company might discover that several departments are buying the same item from different suppliers at different prices, and then negotiate a consolidated contract with better terms. E-procurement systems can also help measure customer and supplier satisfaction levels after implementation. Price benefits are those gains that result directly from adopting e-procurement. These might include lower administrative costs built into product prices, or better pricing obtained through online bidding and auctions. The key point is that e-procurement can influence not only how much it costs to process purchases, but also the prices actually paid. Reflect on this. If your organization could only focus on one benefit category first, transactional, compliance, management information, or price, which would you target? And why? In Vietnam, management information from e-procurement could reveal that different branches of a company are buying the same type of pallet wrap or forklift spare parts from different local suppliers at different prices. Consolidating this spend through one or two preferred suppliers could reduce prices and improve service. Internationally, large firms use e-procurement data to evaluate supplier on-time delivery performance and defect rates, feeding this information into supplier scorecards and future sourcing decisions. Follow-up question: if you had a complete e-procurement data set for your organization in Vietnam, what top 3 analyses would you run first to identify quick savings or process improvements in logistics-related purchases? While e-procurement offers many benefits, this slide reminds us of two important drawbacks. The first is the security risk associated with transmitting information over networks. Purchasing systems handle sensitive data such as prices, contract terms, and payment details, and any weakness in security could expose the organization to fraud, data theft, or reputational damage. The second drawback is that e-procurement can feel impersonal. When most interactions are handled through electronic forms and automated messages, there may be fewer opportunities for direct human contact between buyers and suppliers. This can make it more difficult to build trust. discuss complex issues, or collaborate on innovative solutions that go beyond standard transactions. For logistics and procurement managers, the challenge is to balance the efficiency and control benefits of e-procurement with the need for strong, relationship-based collaboration with key suppliers. A question to consider is, what practical steps could an organization take to preserve and strengthen supplier relationships while still using e-procurement as its main purchasing channel? A Vietnamese company using e-procurement to buy logistics services must ensure that its platform is secure enough to protect tender details, rates, and contract terms from being accessed by unauthorized parties or competitors. This may require working closely with IT and the platform provider on encryption and access control. At the same time, for key suppliers such as strategic 3P to leaders partners, it may still be important to maintain regular face-to-face or online meetings to discuss network design, innovation, and continuous improvement, beyond the transactional interactions in the system. Follow-up question: how might you design a supplier relationship management plan in Vietnam that uses e-procurement for routine transactions but still preserves space for strategic dialogue and partnership with critical logistics providers? Our final slide focuses on broader information technology challenges. The first reminder is that IT is a tool that can help manage organizational problems, but it is not a complete solution by itself. If business processes are poorly designed or people do not use systems consistently and correctly, technology alone will not fix the underlying issues. The slide then lists several specific challenges. Theft of proprietary information and hacking attacks pose serious risks. Protecting websites and systems from viruses and unauthorized access requires ongoing investment and vigilance. The decreasing size and increasing portability of devices such as laptops, tablets, and USB drives make it easier for employees to carry large amounts of data. But they also increase the risk of loss or theft. Finally, employee resistance to IT implementations can undermine even the best designed systems. Without adequate training, communication, and involvement, staff may feel threatened or overloaded by new technologies. As we close the chapter, ask yourself, if you were leading an IT project in logistics, what steps would you take to address security risks and human resistance so that the technology delivers real, sustained improvements? In Vietnam, there have been cases where employees accidentally leaked sensitive customer data or pricing information by losing laptops or sharing documents via unsecured channels. These incidents highlight how easily information can escape controlled systems if basic security practices are not followed. Internationally, well-known cyberattacks on logistics and shipping companies have disrupted port operations and parcel delivery networks, showing how dependent global supply chains have become on stable IT systems. Follow-up question: if you were head of logistics in a Vietnamese firm, what 3 practical actions would you prioritize in the next 6 months to both strengthen information security and reduce employee resistance to new logistics IT systems?